Okay, today we're finding the 6 roots of 1. What in the heck are you talking about, Mr. Server? Well, I'm going to go back to domoivre that we learned yesterday. Do you remember if I said like 3 cis of pi over 2, for example, that you could find that by graphing it? You'd know where that was. Would you just make a quick little sketch? Remember where that is. It's a dot, and it represents a complex number. And then we could square it. Well, then we can also square root it. So that's what we didn't do yesterday, is find the roots of it, the square roots. I mean, if it's a number, you should be able to find its square roots. Like, if I give you 100, you can find the square root. It's 10. All right. So this one, did you find that it had a radius of 3 and it went up in this direction? And so I put a dot right there. And raise your hand if you had that one right. Okay, good. Now, that's an easy one to just look at and say, oh, I could tell you what that is in this kind of format. Would you write it in that kind of format, also known as rectangular? And since this is a complex number, complex rectangular? Well, if you think of it as a point, how far over do you go? 0. How far up do you go? 1. But that's not how you say it. It's not up 1 anyway. It's up 3. But that's still not how you say it. How do you say it in complex form? So it's a complex number. 0 plus 3i. Raise your hand if you had that right. Okay, awesome. Now, we've got the difference here between cis form and, wait a minute, what form is that again? Complex what? Rectangular. Complex rectangular. Okay. And cis form is complex what? Polar. Okay. So what are we doing today? We are, instead of yesterday when we would square things, I taught you how to do domoivre, where it's all about the move of the exponent. Remember that? That goes there, and then this would go here on the top. Okay. Does that ring a bell? Remember that? Okay. Then we are going to, instead of squaring it, we're going to be taking the square root of stuff. But not just the square root. How about the third root, or the fourth root, or the fifth root? Square roots to the 1/2 power. I just remind you for a second, if I just had a number like 9 and I put it to the 1/2 power, there's just one simple answer, and it is 3. All right. And if I had a third root of 9, it would be some weird decimal that would be that times itself, and it would equal 9. Is there a third root of 9? Yeah, the calculator can find it for you. You'd take 9, you put it in the calculator and use the xth root thing, and then you could find the third root of 9. But I don't need you to do that. We are going to be finding the third root of something in cis form. And here's the thing that I think is kind of interesting. At least it's a simple pattern. There are 3 third roots. And if it was fourth roots, there would be 4 fourth roots. And if I ask you for the 6th roots, there would be 6 sixth roots. All right, what are roots again? Yeah, like the answer. Like if I do a square root of 9, it means the answer is 3 because 3 times 3 makes 9. The weird thing that's about these, though, is that, again, if I do the third root, there's 3 separate things where if you cubed those things, they would come out to the same place. All right, trying to make you understand what we're finding here. Again, if I had the number 8 and I did the third root of 8, do you get that that would be 2? And why would 2 be the right answer? Because 2 times 2 times 2 gives us 8. So when we find the answer to the one that I've got on the board here, when we find the third roots of this, any one of those third roots, when times by itself 3 times, would give us this. Okay, so here's how to find the 3 third roots of 3 cis pi over 2. I'm going to show you this one, and then once you see the process, I'm going to have you go back and find the one we started with here, was the 6 roots of 1. Because 1 is a really simple number. 1 is the same as 1 plus 0i, right? Right? Okay, so then you'll be able to use the same process that I just did, which is first I'm going to make it cis form, and once it's in cis form, then you'll follow this little process. Okay, so here's the process. First step is we use domoivre, which is about demove of the exponent. So I'm just going to write another couple of 1/3s up there so that I can move them. It's just a function of my smartboard allowing me to move little chunks like this. So there, that 1/3 goes here, 3 to the 1/3. A bit of a pain because I don't know the decimal, so I can just leave it as 3 to the 1/3. And then this 1/3, this is kind of weird, but think about this. If I have a 1/3 and I multiply it by the top, do you get that that actually is going to be the same as putting the 3 on the bottom? Think of it this way, 1/3 divided by 2. We always put it on the top there, 1/3 divided by 2. Do you get that that's the same as 1/3 divided by 2 over 1? And then I can flip and multiply. 1/3 times flip it 1/2, and that really makes 1/6. So do you get, I can go like that. It's going to make pi over 6. You can do it the long way if you really want to. You can put the 1/3 on top, and then you have to do all the flipping and the multiplying, but it's all going to come out with, like I multiplied it like that. It's going to come out to pi over 6. Okay, so then if I do that, this is gone. But here's the thing that you might remember from the past. What if there are going to be multiple answers? Do you remember me saying that if there's going to be third roots, that we're going to get 3 third roots? If I wasn't careful, I'd just find one of them. By doing this, this would give me one of the roots. One of the 3 third roots. And it would be 3 to the 1/3 cis, and then multiply that out, pi over 3 times 2 is 6. There it is. That is one of the third roots. Because if you take this times itself 3 times, it would go back and give me the original one. Since I don't have it anymore, it's that. It would give me that back again. Okay. But if I need multiple roots, who wants to take a stab at what they think I'm going to put at the end of it? Come on. It's like the other kind where we had to get a whole bunch of answers. Remember those on a test recently where you had to get like not just 2 answers, but it came out to like 6 answers? Remember doing those? Yes? Say that again. Plus 2 pi k. You got it. Because that'll keep adding 2 pi to our angle, which, think about it, if you add 2 pi to the angle, don't you just get another angle that does the same thing? Okay. If I keep adding 2 pi to my angle, I have to also include that in the whole domoivre thing, because this is the angle. It's really this plus that, and k can be 0, which would mean it's like it's not even there. That cancels this whole term out. Or k could be 1, in which case I got to add 1 set of 2 pi. Or k could be 2, or k could be 3. And how many times do you do it? Well, you know, if it's 5th roots, we will find 5 of them. And the way you would be able to tell if you had gone too far is that your answers actually start looping back and giving you the same answer you had in the first place. I'll show you that later. So it's almost like you can't mess this up, really. You just keep on finding answers until they start repeating themselves. Okay, so all I've really done is, if the problem had been, whoa, hold on a second here, this 3 cis pi over 2. You know what? I'm gonna cheat right now and change this to an 8, just because it'll be so much easier. I gotta take the third root of an 8, so let's just change that to an 8. Then I was asked to find the third roots. There'll be 3 of them. I'm going to put it to the 1/3, which then forces me to take my 1/3 here, and I'll have another one, and another one, and do the domoivre process. That goes here. This goes here, and I showed you why it actually can multiply in front like this. And then last, this one has to also multiply by the 2, which again is like multiplying it like this. It's going to make it 2 pi k over 3. Now, the reason I changed that to an 8 is just so this will work out so much nicer. I don't have to drag my 2 to the 1/3 all over the place. 8 to the 1/3 is nice. What is it? 2. 2 cis pi over 6 plus 2 pi k over 3. Now, pause for a second and note these 2 would be a pain in the butt to add because they don't have a what common denominator. So now we should multiply the right fraction by what over what? 2 over 2. Now it's 4 pi k over 6. 2 cis pi over 6 plus 4 pi k over 6. And I know it's not reduced, but it's on purpose because we wanted it to have a common denominator. And now you're all set. And now you just have to do k equals 0 gives me this answer. K equals 1 gives me this answer. K equals 2 gives me that answer. And do you get, that will be 3 answers. But just for fun, I'm going to have us do k equals 3, because it's really common, because people are thinking I need the 3/3 roots, and they keep going until they hit 3. Guess what? The answer is going to loop back and be the exact same thing as what it would have been if with k equals 0. Okay, so let's do k equals 0 first. Well, if k equals 0, I just have this whole thing except the k equals 0 means this whole part's going to cancel off, so it's gone. So I have 2 cis pi over 6. Done. When k equals 1, I have 2 cis pi over 6 plus 4 pi times 1 over 6, which if I simplify it down is 2 cis 4, and this is 1 pi over 6, makes 5 pi over 6. And the last one, 2, I should probably not use red, so just keep consistent here. 2 cis pi over 6, or 1 pi over 6. Maybe I should be putting a 1 here. It doesn't, you don't need it, but I should be consistent at least. Plus 4 pi times, this is k equals 2, so I'm putting a 2 here over 6. And then that's 2 cis 1 pi over 6 plus 8 pi over 6 makes 9 pi over 6, which if I reduce it makes 3 goes into both of them, 3 pi over 2. Okay, and like I said before, I'm just going to do one more for fun. You don't even have to do this, but I'm just going to show you why we can logically stop doing this. It isn't just like a because Mr. Server said. 2 cis 1 pi over 6 plus 4 pi times 3 over 6. That was because k equals 3, so we put a 3 right there. And now look what happens. 2 cis, and then 1 pi over 6 plus 12 pi over 6 makes 13 pi over 6. What did I do with my angle? I just went past 2 pi. And that means it's just going to recycle back around to, if it just went just barely past 2 pi, think about it this way. If I just went all the way around 2 pi and then up another like 30 degrees, it's like I would have been able to just get that by doing 30 degrees. See what I mean? So going around past 2 pi here is exactly the same as this one, which is just 1 pi over 6 past the 2 pi. So, moral of the story, if you're doing the fifth roots, you're going to get 5 of them. And that does mean you'll stop on one less than. So if I want the 3 third roots, I do k equals 0, k equals 1, and k equals 2. You don't do k equals 3, or you would have been getting the fourth one. And the fourth one is the same as the very first one that you did. So you don't need to do this part. So notice if I did the 3 third roots, I used 0, 1, and 2. That is 3 things. Okay, let's see if you, by yourself now, actually, I'm going to give you a partner for today. With a partner, can figure out the 6 roots of 1. Hint, first, make it into cis form, then do the 6th roots, which is again to the power of 1/6, and you'll do it 6 times. Remember to add plus 2 pi k in there. All right, I think that's enough. These 2 rows slide next to each other. These 2 rows slide next to each other. These 2. And for today, would you be willing to move back and work with him? He has no partner. Sad story. All right, I'm going to pause for a second while you guys work on that. Okay, let's see how you did. If you're not done, at least you should be done with this much. Cis form would be telling me that in polar. What's the R of it? 1. What's the angle? Well, you could argue it's 2 pi, or you could say it's 0. And it doesn't really matter which of those two you pick, but I would default to 0 because if you have 2 pi, 0 is simpler than 2 pi. So 1 cis 0. Then you're taking 1 cis 0 to the 1/6. Sorry, that's a 0, not a theta. All right, so then I'm going to put it to the 1/6. The nice thing about 1 is 1 to the 1/6 is just 1. I hope you didn't drag a 1 to the 1/6 through your whole problem, because the 6th root of 1 is 1. So 1 cis, and then I also have to bring this down onto the 0, and 0 times 1/6 is kind of boring, right? Because 0 times anything is 0. But don't forget the whole, it's really 0 plus 2 pi k. So then, when I bring that 1/6 down to the front here, it distributes to both parts. Yeah, the 0 part makes it just 0, but that part becomes 1 cis 0 over 6, but that's not really anything, plus 2 pi k over 6. Now, yes, you can reduce that to 2 pi k over 3. And then you need to do 6 cases of it because it's the 6th roots, right? So then we need k equals 0, k equals 1, k equals 2 ad nauseum. So if I put in 0, 0 goes here, and it's just 1 cis 0. I always want to say theta when I do that. I'm going to try that again. 0. Then I'm going to say 1 cis, and then this is 2 pi, and the k is 1 over 6, which, yes, you could reduce to pi over 3. And the next one is 1 cis, and again, just keep doing that. Now I'm going to put in a 2 where this was, so that's going to become 4 pi over 6. But I want you to notice a pattern, because I don't want you to just be a mindless automaton. How much did I add to get from here to here? 2 pi over 6. How much did I add to get from here to here? 2 pi over 6. Are you seeing a shortcut? So then I can just go 1 cis, and I add 2 pi over 6. And that's going to become 6 pi over 6. I'm just keeping it in 6 to see the pattern, okay? I know 6 pi over 6 is just pi. Then it's 1 cis, and then another 2 pi over 6 is going to make 8 pi over 6. And I just keep going like that until I hit 2 pi again. You know what I'm saying? If I get to 12 pi over 6, isn't that the exact same thing as 12 pi over 6 is the same as 2 pi, which is like 0? All right. So I better just finish. I got, this is k equals 3. This is k equals 4. I just have one more. K equals 5. 1 cis 10 pi over 6. If I had, sorry, not 16, 6. If I had gone one more, it would have been 12 pi over 6, which would have wrapped back around and been this again. Okay. Raise your hand if you think you could do that. Cool. Let's consider one of the harder things of this chapter. I don't think it's that bad. Just if you get the whole plus 2 pi k thing, it's not that bad. Especially when you start catching on to the pattern, like, oh, all I'm doing is adding 2 pi over 6 to the angle. That's it. All right. Now, I want you to think for a second, though, that what would that look like if I graphed it? I have a radius of 1 every single time, but I have different angles, right? A radius of 1 with an angle 0 is like that. A radius of 1 with an angle of 2 pi over 6, which reduces to pi over 3, would be like that. And then it's like that. And then it's like, it goes around like that. And how many of them are there? There's 6 sixth roots. And it kind of makes a circle. Kind of. If I was doing the 7 seventh roots, there'd be 7 dots that are all the same distance, the same r. All right. That's all I needed to teach you for today. It's kind of cool. So then let's get to the assignment. Find the part that says assignment day 5. I know it's kind of annoying, but technically yesterday was day 4, so today is day 5. Come on, where are you? I must have hit the back button a couple times. Getting close. There, finally. Okay. Once again, we're slowly easing you into tougher and tougher cis. Like, that's not in cis form. So then you got to go find that in cis form. And we're using angles you know. It doesn't maybe look like we're using angles you know, but do you get since there's 2's and root 3's and 1's, when the time it's done, it's probably the 1, 2, root 3 triangle? Okay, so it's probably your 30, 60, 90 triangle. It's just got strange looking sides. All right, so start by making that in cis form. I am going to cut this down to a reasonable size. You can do the 2 that are circled here, 58 and 60. And then on this one, we're just going to do 67. This is exactly like what we just did. It's the 2. Don't be thrown off by them saying square roots, because that's the second roots, the 2 second roots of z. All right, so put this into cis form first, then do the plus 2 pi k thing, and then just do it 2 times, because you need the 2. All right, and then one more, this one. The 3 cube roots, or third roots, of just I. Remember, just I is really I plus, 0 plus I. Don't forget that it's got its 0 real component. All right, that's it. Do it up to there, and you're done. That's all I got for you for today.